Hello everyone. Hi Prajwal. Hi Captain. May I know who is this Captain? Guys, chat is enabled. Okay. Try to put a message in a chat box once. Am I audible, right? Audio is not clear. Shashi, once you check it, bro. Now check it once. Is it clear? Is my voice is audible right properly? Yes. Thanks, buddy. We'll wait for the 2 to 3 minutes, guys. Okay. Soon after 2 minutes, we'll start. And very good evening to all. Yes, Prakriti. Good. Good evening. Okay, if I on my camera means check whether my voice is properly audible or not. Actually, since from last 3 days, I didn't switch on my camera even too. Okay, there was a network issue, I know, but tell me whether now it is confirm me, just confirm me. Is my voice is clear, right? When I switch on my camera? Is my voice is clear, right? During when camera is on, no? That time I'm asking. Hello. I think breaking voice. Okay, it's better. We'll continue in this mode only. Okay. Yes. Captain, may I know your name? That's okay. Good evening, Ishwari. Good evening. Guys, actually yesterday I told you all we are going to discuss few more numericals about electrostatic potential and flux like that. But the thing is that actually I put a thumbnail in a YouTube. Okay, we are starting capacitors 3 days back itself. So I can't able to change that one now in YouTube. For that reason, I'm starting the capacitor from today onwards. Okay. We'll take another one day after finishing this capacitor. We'll take few more numericals while solving the capacitor chapter numericals. We'll solve along with the electric potential and flux. Cool. And I give 2 to 3 homework problems also. Did you guys check that one? Guys, 2 to 3 homework question I assigned. Okay. Is there anybody solved that one? If you had any doubt regarding about those questions, they are actually belongings to previous year NEET questions. And the NEET, yes. Okay, welcome to all of you guys. We'll start our session today. Okay, still only 7 members are there, but I will try to give a brief idea about the capacitors. Okay, capacitors क्या होता है? Do you know what is this capacitor? Yes, Gayan, good evening. Have you heard this voice capacitor in your daily life? Guys, I'm not yet started chapter. Please do give a response. Do you know or not? Capacitors. Yes. Okay. Where we will, okay. Good. Okay. Those who don't know, I will show that what is that capacitor. Okay. I will show you the capacitor क्या होता है. देखो इधर. Guys, look at here. This is capacitor. What you people are in front of this screen know. Screen is visible, right? Something I'm moving here, right? This is called capacitor, guys. It's a device. Yes. Dekho. This is a device actually which stores electrical energy. Okay, like this it has. इसके अंदर क्या क्या होता है उसको स्टडी करना है आज से हमको. That is what the full study about the capacitor. Okay, this is capacitor basically. उसका ऊपर भी कुछ कुछ लिखा है देखो 33 microfarad 63 volt something is there, no, right? Note on these points which are I will tell you what are those. And then उसका नीचे भी एक दो poles are there. Right? Actually, these are not poles. Okay, these are the we call this one as a terminals. Okay, we call these two are terminals. Guys, this is an electronic device. That's it. देखो ऐसे होता है. If you open any electronic device like mobile charger, anything, you can see like this device as inside it. Okay, what it will do and what is the benefit of this one and why we are using this one and everything I will tell you in this class itself. Okay. Is my extended screen is visible right now? Tell me once in a chat box. Now I extended the. Thank you, guys. Thank you, Sagar. Okay. Done. Okay, Sanket. Why we are using this capacitor means to store the electric charges. Why means to store electric charge. You might be asked, guys. Yes, good evening, Yashaswini. Okay, capacitor means store the electric charge, and you might heard this another sound also. Condenser. Do you know, guys? This is condenser. Actually, in rural area, farmers will use this one to start the motors. Electric starters में होता है. Correct ना? If they are getting very low voltage means to start the motor, borewell pumps, they will utilize this one condenser. Okay, what it will do? Bomb. Hey, that is TNT. Manthan, the bomb. It is not a bomb. Okay, condenser. It is nothing but an electrical device. It is nothing but capacitor. Nothing but capacitor. It will stores the energy. You might be asked one more question also, sir. Battery also stores energy, and then clock. The what we are to run the clock, we are using cell. That is also stores the energy cell. But why we need capacitor? Okay, Mansan. Okay, I got it. Good evening, Sanjana. Correct now? What I'm explaining? Yes. Why we need to use the capacitors? We can to store the electric charge. We can use. Good evening, Sanket. We can use cell itself or battery itself. By why it is needed capacitor? That's the biggest question, right? In your mind also it will come. But there is a big use of this one. क्या है? Actually, cell means, मान लो this is a cell. Okay, it will give constant potential. Constant potential means it will be run. If you're going to put this cell, 3-volt cell hai. Okay, if you put this cell to any clock, means it will give the energy. It will liberate the energy for a long time. Your clock will be run for a long years also. Correct now? But condensers are not like that. And moreover, if once it is discharged, once it is completely discharged cell, okay, again you can't able to charge this one. Correct now? But capacitors are different. Kya karta hai means if they will actually charge very suddenly. Okay, what happened? They will charge suddenly, and in the same time, meantime, they will discharge also suddenly. Discharge also suddenly. Okay, based on this function, charging suddenly and discharging suddenly. Okay, it has a wide application in our dynamics. Kya hai wide application? First, I will tell you the fan. Okay, don't feel like that. Sir is bring today fan on the screen, fan, camera, and something what. Sir, whether sir is doing some Flipkart sale or not, like that. Don't think like that. Okay, there is no big billion day going on here. To run this fan, we need to supply the electrical energy. Correct now? Do check your home also in your home today. Okay, we are observing only this fan every day when it is rotating. Correct now? But try to analyze what the fan here on condensers also they are going to keep. Okay, without condenser, we can't able to move this fan a little bit also. Do you know why? Do you know why? Actually, when the current which is coming in front of our home, so inside of our home, it is 220 volt. It is 220 volt. That 220 volt capacity voltage will not rotate the fan. That amount of current will not rotate the fan. It requires more amount of energy. That's why what we will do here, will in the parallel connection, we are going to connect a condenser. Condenser nothing but a capacitor. We're going to connect one capacitor to it. That time the current will be charged to the capacitor. It will store the energy suddenly, and at the same time when it is storing the energy, at the same time fan is trying to rotate in a small velocity. But when the condenser will be discharged suddenly, at the time time will start to rotate very fast. Means to move the fan, whatever the amount of current we have, that is not sufficient, right? That's why what we will do, we'll fix a condenser or capacitor that will make internet stability unstable. Okay, that time what it will do, it will start to rotate the fan perfectly. Correct now? That is the best daily life applications. What? Yeah, Gayan, I got to know. That's why I switch off my camera. Okay, here this capacitor, it will do to rotate the fan. It will give up good energy. Correct now? In a similar way, already I told you that condensers. Okay, farmers will use this one in a pump sets. Correct now? Whatever the current is there, no, sometimes voltage बहुत कम होता है. That time, that amount of voltage required to rotate that motor, it will now, we can't able to provide directly. Correct now? At the time, they're going to connect the condenser through parallel. Okay, whatever the current they are going to passing to the pump set no, उसके लिए parallel connection में condenser को fix करता है. When it is will be fixed no, that time extra suddenly it will be charged and suddenly it will be discharged. This is a working function of condenser. Suddenly it will be charged and suddenly it will be discharged. When it will be discharged, a large amount of current will be flow through in the circuit. That time the motor pump will be start to rotate. And then you might be see the cameras also. Camera flash, do you know? Camera flash, flashes. How the camera will be give the flash. It is also basically condenser. A small capacitor they are going to insert inside it. Okay. When you are going to click on it, no, that energy from the cell, it will be transferred to the capacitors which are present inside, and capacitor will be charged first. When it is will be discharged very fastly, that time a huge amount of flashlight will be come from this camera. Okay. It best in a simple way I will tell you guys, condenser or capacitor are we are using for to store electrical energy and main function are there sudden charging and sudden discharging. Yes, Vastik. Yes, bro. Right. Clear na? Introduction, is it enough, right? Is it enough, right? Introduction for the capacitor. We'll move on. Okay. I moved the second slide. Is the slide is visible, right? Let me know. Behavior of a conductors in an electrostatic field. Yes, bro. Definitely. Sure. Okay. Behavior means before coming to the construction of a capacitor, how the capacitor will be constructed, we have to know about some behaviors of the conductor, which we already discussed in a previous class. What are there? The net electric field intensity in the interior of the conductor is 0. Okay. Means any conductor, if I'm going to consider, okay, like this, it is there means, okay, inside the electric field, okay, inside in this electric field will be equals to 0. Okay, this is the first point. Inside there is no electric field in the conductor, right? This already we done this one in our previous classes, means in our first chapter itself. Electric field inside the charged conductor will be 0. Correct now? Second point, electric field just outside the charged conductor is perpendicular to the surface of the conductor. Electric field lines, how they will be present outside of the conductor. If I'm going to place some charges, means always they are perpendicular to the surfaces, right? 90 degree. Correct now? Okay, isko chhod do. And then we'll move on to the next point. These are the points, just I'm remembering the concepts. Okay. Third point, net charge in the interior of the conductor is 0. एक conductor है, conductor के अंदर net charge always be, it will be 0, because if charge will be present inside the conductor, then only it has a field, or else there is no field. देखो इधर, the charge are temporarily separated, the total charge of the system will be 0. If you are going to separate the charge for a temporary time, okay, then it will be 0. Since देखो electric field inside it will be 0, because conductor, therefore Q value means charge. If charge is not inside the conductor, means then electric field value will be 0. Simple way we need to analyze this one. Correct now? And then charge always resides on the surface of the conductor. This is also we know in a, this is all about previous class only, but it will be connected to the capacitors concept. Okay, for that reason I'm saying, okay, if we have some charges, means if we are going to give the charges to the conductor, means these charges will be always trying to occupy the surface area of that conductor, not interior part, always be on the surface, right? And then meanwhile, if you are getting any doubt, means let me know. Electric field normal to the conductor. Yes, bro. Always it will be normal. If electric field is there here, means if a electric field be moving in this direction, means it will be perpendicular to the surface of the conductor. And then fifth point, देखो, this is very important. Electric potential is constant for an entire conductor. Electric potential value होता है ना, V value. We took V value as a K, Q, upon R. Okay, here whatever the value we will get for the potential, this potential value will be always constant. Constant means, मान लो we got 3 volt for this material. This 3 volt is fixed one. It won't change. Correct now? That is what electric potential constant to the entire conductor. That is dV by dr. Okay. इलेक्ट्रिक पोटेंशियल एंड एज वेल एज द इलेक्ट्रिक फील्ड लाइंस, इसके लिए रिलेशन होता है ना, इसको रिमेंबर करना है ऑलवेज. एंड देन सरफेस चार्ज डिस्ट्रीब्यूशन मे बी डिफरेंट एट डिफरेंट पॉइंट्स. मींस चार्ज डिस्ट्रीब्यूशन करते हैं ना आप. ओके, द वैल्यू ऑफ चार्ज डिस्ट्रीब्यूशन, सरफेस चार्ज डेंसिटी. ओके, दैट वैल्यू विल बी डिफरेंट, मे बी डिफरेंट फॉर डिफरेंट प्लेसेस. मान लो एट दिस पॉइंट इफ आई एम गोइंग टू कंसिडर, मींस at this point, okay, here in this surface in a unit area, okay, मान लो I will take a unit area itself, it is better. Okay, देखो इधर, if I'm going to take this unit area, okay, here 3 charges are there. In a similar way, in a same unit area, if I'm going to take here, means okay, here only 2 charges are there. Correct now? This area contains only 2 charges, this area contains 3 charges, means here surface charge density sigma value is greater compared to this place. Correct now? It will be different from the different points, right? And then next point kya hai dekhna hai. Every conductor is equipotential volume, 3 dimension rather than just equipotential surface. No need to remember this one. Actually I told you that every conductor, if you consider this a conductor, it has a fixed potential V value. Okay, it will not change. V value will be constant for a conductor. Okay, these are the 6 points which you need to remember. What are those 6 points? In a simple way I will try to remember. Dekho guys, here first 2 charges are, first 2 things are remember, right? Net electric field intensity will be 0 and electric field will be always perpendicular to the surface, always perpendicular. Like this it is not possible. Okay, electric field intensity will not inclined at any cost. Okay, and then net electric charge inside the conductor will be net charge inside the interior of the conductor is 0. If charge will be, okay, charge if they are showing inside means the charge value will be 0. Always they are occupy the surface only, like this. If you give the charges means they will be resides on the surface, not interior of the charge. And electric potential V value is constant for a particular object. If I'm going to consider an object means V value will be constant. And then surface charge distribution may be different at different points, means sigma value will be different at different points. Clear enough? These are the 6 points which are required for us today. Okay. Daily guys, just a minute, I will come. Thank you for bearing the time, guys. Show second point, sir. So second point. Just a minute. Yeah, it is a second point. Is there any doubt? Sir, class doesn't show sound. Is lively, interesting like every time. It was, sir. No. It is good only. What happened? Bro, what happened? Rajat, are you fine, right? कोई problem nahi, guys. Okay, we'll go. Okay, sometimes it happen. कोई problem nahi. Okay, we'll match up that one. कोई problem nahi. This is the second point. Okay, electric field just outside the charged conductor is perpendicular to the surface of the conductor always. Okay, like this, if any case, if you're going to see like this, means it is absolutely wrong thing. Okay, always they are perpendicular. Electric field lines always be perpendicular. Right now, no need to go through this theory, yaar. Okay, koi problem nahi. Right? And then, yeah, electrical capacitance, guys. We'll come across to the electrical capacitance. Okay, dekho idhar. According to H.C. Verma sir. Okay, I referred H.C. Verma book today. What they given, no. According to that, we required on capacitor means हमको capacitor बनाना है. Okay, capacitor बनाना है means we required conducting plates. Means conductor चाहिए हमको. Okay, I took one conductor like this. I took one conductor. Okay, capacitor होने के लिए 2 plates are required. That's why I will take another one conductor plate. These are the 2 metal plates. What are these? 2 metal plates. Okay, now what I will do, I will connect these 2 metal plates with a external battery. Okay, connect kiya maine. Okay, now the circuit is not completed. Correct na? This is positive, this is negative. Battery hai. Okay, circuit is not completed. If I complete the circuit, current is start to flowing through it. Okay, when current will be start to flow through it, the positive potential, the positive terminal which I connected to the plate A, it will be get charged with positive charges. Okay, it will get charged by positive charge, and negative connection which I did for the metal plate B, it will be get negative plate here. Okay, now actually dekho guys, one plate, on one plate positive charges are there. Okay, इसका charge density shall I call sigma plus, and similarly इसके ऊपर charge density है sigma minus. Now tell me, on these 2 plates, I put a charges. Okay, now charges are present on the plates. Shall we call this one as a capacitor? Can we call this one as a capacitor? Rajat, tell me now. Swastik, यशस्विनी, कैपेसिटर्स क्या होता है ना, चार्ज स्टोर करना. ओके, ऑलरेडी I take out 2 plates. Okay, on the 2 plates I pass the charges, bro. Okay, now these 2 are capacitors, right? Yes, of course. According to him, guys, according to H.C. Verma sir, okay, what he told, if you're going to give a charge to any metal plates, okay, and they are separated with the one small distance, a distance है ना बहुत छोटा होना चाहिए. Okay, then we can call this device as an capacitor. We can call this one as a capacitor. Conditions क्या है? We need to charge the 2 plates. Means we require 2 metal plates. Metal plate. Okay, and we need to charge the 2 metal plates. What we need to do? We need to charge these 2 metal plates. Okay, and then these 2 charges should be opposite poles. Okay, when these 2 will be get charged, okay, at the time, one more point we need to concentrate here, these 2 should be separate, guys. This should be separate with very small distance. Okay, this construction is known as the capacitor. I think it is understood, right? 2 metal plates are charged and they are separated with a small distance. That is known as the capacitor. That's it. Now this has become a capacitor itself. And one more point, capacitor होने के लिए कोई shape नहीं चाहिए. Whatever the shape of metal you take. Okay, but the thing is that we need to keep these 2 things in a very close together. That's it. Correct now? Right? Is it understood? And then one more point we will discuss here. What is that means? Capacitance. Okay, capacitance. In a first page I show guys. Okay, some capacitor figures are there that time. Okay, there on the capacitor you might be observed that 16 microfarad like this they mention. Correct now? Here 16 microfarad is there, no? On the cell, if you're going to take one cell means cell ke upar hota hai 3 volt. Okay, it is representing that one. Yes, exactly right. Ability to store charge. Yes, bro. Yes, exactly right. Okay, here 16 microfarad means it is a capacity of that capacitance. Means a combination hai na, this combination made, right? Now it is charged. इसका capacity कितना है? मान लो 16 microfarad मैंने बोल दिया. It is the capacity. Means capacitance of the capacitor is different by you whatever the metal we are using. मान लो, I will give a best example to this one. Okay, every time whenever I give this example to inside the classroom, no, my students will be get really get next level of confident to the capacitor. What is that means? Guys, you know my you know chips, right? Chip means memory cards. Memory card. We are usually called memory cards. What we are going to keep inside the mobile. Memory card. Yes, exactly right. Okay, on that memory card you might be observed like this. इसके ऊपर लिख सकता है 4 GB or else 6 GB or 16 GB. Correct now? What is this? 6 GB, 4 GB, 16 GB? Storage. Yes, obviously storage. Correct now? Here 16 microfarad means it is nothing but storage of the electrical charge. Storage of the electric charge. If you're going to take 4 GB memory card means 4 GB capacity only it has. 4 GB capacity only it has. In a similar way, if I constructed one capacitor, okay, here I randomly constructed like this. Usually whenever we are constructing no parallel plates we will use. Okay, parallel plates we will use like this. Okay, मान लो they are separated with a small distance with a positive and negative charges. This is a construction हो गया है. Okay, construction भी हो गया है इसके अंदर. Now it is ready to use capacitor. Okay, इसका storage capacity if I say 16 microfarad means it is fixed one. correct है? इसका capacity होता है, right? Capacity means how much that capacitor will store the energy, that is known as the capacitance of the capacitor. I'm just giving the introductions. Okay, next we need to find out along with the numericals or mathematical function. That's why capacitance मालूम हो गया ना? Capacitance क्या होता है? Quick response. Give me quick response in a chat box. Yes, that too great. Okay, देखो इलेक्ट्रिकल कैपेसिटेंस क्या क्या होता है बोलता हूं मैंने. Capacitance of the conductor is defined as the charge required to rise the potential through this unit. क्या होता है इसके अंदर? Look at here. Yes, I will tell you. I will tell you once again. Okay, bro. Listen. First, listen this one. Okay, either two parallel plates are there, guys. Okay, these are the two parallel plates. Okay, I made these two with some distance, means separated by distance d. इसके ऊपर plus sigma, इसके ऊपर minus sigma charges are there. Means here plus charges are occupied means obviously another side of plate में negative charges are start to induce around it. Okay, we call this one inducing of charges, negative charges. When these two will be inducers, no, electric field will be developed from positive charge to negative charge like this. Electric field will be start to develop. Correct now? If electric field will be start to develop means across these two plates, potential means V value will be start to develop. Means start to increase. Okay, that time इसका कैपेसिटी भी बढ़ जाता है. करेक्ट ना? नाउ इसका कैपेसिटेंस एक्सप्लेन करना है मींस देखो इधर capacitance explain करना है means will call here this charges are there, no, how many charges will come and occupy this plate. Okay, I will call this charges as an q. Okay, this charge will be start to occupy one by means electric field will be developed, and if electric field will be developed means potential will be start to rise between our two plates of the plates. Correct na? Means charge is actually directly proportional to voltage. Voltage means potential. Shall we call this one now? This potential is increasing just because of the accumulation of a charge on the plates. On this plate, man lo, when I initially connected this one to a battery, guys, okay, initially connected to the battery, one charge came here, one negative charge will be induced. Okay, and second charge came, second negative charge will be induced here, means one by one electric field will be start to develop. In a similar way, potential also start to increase, right? What I am saying, potential also start to increasing. This potential means voltage across these two plates will be increasing just because of the charges are adding onto the plates. प्लेट्स के ऊपर चार्ज ज्यादा हो रहा है मींस पोटेंशियल भी ज्यादा होता है. दैट्स व्हाई आई टुक हियर q is directly proportional to v. Clear na? And it is directly proportional. That's why what I will do, I will remove this proportionality constant. I will introduce one constant quantity here. We call that one as an c. C stands for, guys, actually capacitance of the capacitor, electrical capacitance. Okay, C stands for electrical capacitance. Into V, we will multiply. Okay, here if I want to find out the electrical capacitance, C value find out karna hai, means any capacitor is there. Okay, uska capacitance kitna hai पूछता है. That time you want to find out that one means C is equal to, you will write Q by V. This is the formula for capacitance. Capacitance of any capacitor. Is it clear? Let me know once in a chat box. Yes, that's great. Swastiks, I will explain you, bro, that one. Okay, again I will explain you, don't worry. Okay, and then guys देखो इधर कैपेसिटर symbolize करने के लिए we will use this symbol. Okay, दो lines along with connecting wires. We call this one as an connecting wires. These two are the parallel plates. Okay, like in this way we will trying to show the capacitor. Okay, and if in case I will give one more option also, guys देखो इधर find the correct option among these two. I will tell you. Okay, I will give a option. क्या है option? देखो ध्यान से सुनो. Choose the correct symbol of capacitor. Question is choose the correct symbol of capacitor. Okay, A, B, C, D. There are 4 options, guys. All are made by plates only. All are made by plates only. Now choose the correct option for the symbol of capacitor or else capacitor. Okay, good. Good. In an initial point only I told you guys, capacitor के लिए कोई shape नहीं है. Okay, if you do like this also, it is also correct. Okay, just a minute. Yeah, if you take like this also, it is also correct only, but it should be plate and it have a capacity to hold the charge. That's it. And this should be separate with a small distance. A small distance के साथ separate होगा, it is enough. Okay, this 4 symbols also correct only. This 4 also correct symbol, right? when I usually read this sentence, no, I was also get shocked with that one. Okay, but when I thoroughly studied the H.C. Verma book in a starting page only, okay, in a starting page only, you will get an idea about it. Those who don't have an H.C. Verma, try to download this one from Play Store itself. It is available. Okay, try to go through it. 4 also right. Is it clear, right, up to this point? Is it clear? Yes. Give a response, yeah. Yes, good. Dekho. Up तक we got to know that capacitance we're going to find out by using the formula Q by V. Correct na? Okay, done. Okay. Next question is that if I ask, is that capacitance of this capacitor depending upon the charge and voltage, means okay, which one you will choose? I will ask. Okay, capacitance of the capacitor C will depend on the which factor among these two, charge or voltage. C stands for capacitance of the capacitor. Okay, actively respond, give a response, guys. Give a response actively. Directly on Q, inversely on V. Very good, very good, very good, very good. But I will tell you, these two are wrong. These two are wrong. Why means, I will tell you again the story of the memory card. Memory card, what we used here. Okay, manlo, this is a memory card of 4 GB. Okay, it is the capacity of the memory card, right? It has a storage. Okay, इसका storage के लिए files चाहिए. It required files or images, whatever we are clicking in a phone, that is required. Okay, is this 4 GB? देखो, the answer सुनो. Is this 4 GB? Is this 4 GB storage? Is it depending upon the file which you are putting inside it? आप क्या फाइल इनसाइड पुट कर रहा है ना मेमोरी कार्ड के अंदर, उसके ऊपर डिपेंड हो गया क्या 4 GB? टेल मी. नो राइट, नो राइट. In a similar way, capacitance of the capacitor does not depend upon the charge and as well as voltage. ये दोनों के ऊपर डिपेंड नहीं होता है. Here charge means files what you are giving inside. Voltage means इसका potential voltage storage कितना full होता है, that is voltage. Correct ना? Files are the charge, storage are the storage, how much storage it has, that is represented by voltage, and GB 4 GB is there, no, it is capacitance. Write that. Okay, it is does not depend upon the charge and as well as the voltage. Guys, so no, I will tell you. Purnima, yes, I will tell you. It is actually depending upon, if I'm going to take one parallel plate like this, 2 parallel plates I took here. Okay, इसका लेंथ है 5 सेंटीमीटर and sorry breadth and length है 10 सेंटीमीटर. Okay, इसका distance or separation will be 0.1 centimeter. Next I will take another capacitor like this, plates like 2 centimeter, 5 centimeter. Okay, and separation distance again 0.1. now देखो इसका dimension है ना, ये दोनों को डायमेंशन आर वेरी डिफरेंट. करेक्ट ना? ये दोनों को डायमेंशन डिफरेंट हो रहा है, मींस चार्ज एक्सेप्टिंग एबिलिटी विल बी डिफरेंट होता है. करेक्ट ना? चार्ज डेंसिटी चेंज होता है. ओके, इट इज एक्चुअली कैपेसिटेंस. इसके ऊपर चार्ज होता है ना, देखो 1 2 3 4 होता है, इसके ऊपर 1 2 3 हो सकता है. करेक्ट ना? इन अ सिंपल वे इफ आई वांट टू टेल मींस भगवान इसके लिए एक अच्छा भला किया है, मीन्स एक्चुअली गॉड इज गिवन सील ऑन दी ईच एंड एवरी प्लेट्स. ओके, आपका कैपेसिटी इतना ही है, इतना ही स्टोरेज करना है, लाइक दैट. ओके, इसका कैपेसिटी मान लो ए प्लेट का 10 माइक्रोफैराड है, मींस 10 माइक्रोफैराड ही होता है। इसका कैपेसिटी 8 माइक्रोफैराड है, दैट मींस माइक्रोफैराड 8 माइक्रोफैराड इज इट। Okay, it is fixed one, right? What I'm saying, understanding, right? It will not depend upon the charge, how much you people are giving and how much voltage is developing between them. Yes, Rajat, thank you, bro. Right, in a similar way, guys, actually you studied no Ohm's law. Ohm's law in 10th standard you studied, that is V is equals to IR, correct ना? R के लिए resistance is equal to V by I, you people are usually लिखते थे ना इसको, as usually in next chapter you have to study this one. Here resistance of the material doesn't depend upon these two factors, they are not dependent. In a similar way, capacitance of the capacitor also not depend on the charge, not depend on the voltage. On which factor then it is depending? That is the biggest question. It will depend upon the shape of the capacitor plate. कैपेसिटर का प्लेट शेप कितना होता है? यस, लेंथ, हाँ, दैट वन ओनली. एंड देन मटेरियल मीडियम. ओके, मटेरियल के ऊपर डिपेंड होता है मटेरियल. ओके, यू माइट बी टेक mica sheet or different sheets. I will explain that in the next page. Okay, based on the material medium it will be changed. Okay, done? Is it done, right? Understood? I will talk one more point here and then I will move to the next concept. Good. Then capacitance हो गया. Capacitance के लिए formula derive किया हम Q by V. We got to know that this is a physical quantity. Physical quantities all are having a SI unit. Correct ना? SI unit क्या होता है इसके लिए? बोल दो इन chat box में. Look at the formula and write the SI units. Formula देख के SI unit लिखना है. Don't tell directly. First speak. पूर्णिमा श्रीदेवी. हाय रे यार. Okay. This is कूलम. चार्ज के लिए कूलम डिवाइडेड बाय पोटेंशियल के लिए वोल्टेज और वोल्ट. कूलम पर वोल्ट is the SI unit for capacitance. Clear? Done. Okay, and also guys, this 1 coulomb per 1 volt, if I am going to write, means we call this one as an farad. Okay, farad, F-A-R-A-D, farad. Okay, farad is the SI unit for capacitance of the capacitor. Resistance के लिए होम साइंटिस्ट आ गया था. कैपेसिटेंस के लिए कौन आता है? farad आता है. क्लियर ना? Okay, now take 1 minute of time. Take exactly 1 minute of time and tell me what is the dimensional formula for capacitance of the capacitor. Dimensional formula लिख सकते हैं ना? This is very important, guys. Whenever I will derive the equation, no, I never leave this dimensional formula. Faraday, not Faraday, Faraday itself. Dimensional formula बोल दो. हम तो उड़ गए. If you don't know dimensional formula, means try to develop the dimensional formula by knowing the SI unit. SI unit से dimension formula बनता है. Yes, good. Purnima, well tried. रजत, थोड़ा सा मिस्टेक हो गया है, आई थिंक, थोड़ा सा. आई विल टेल यू, नो वरीज. ओके, देखो इधर, कैपेसिटेंस मींस Q by V, करेक्ट ना? Q चार्ज के लिए ओके रख दो इधर, Q डिवाइडेड बाय वोल्टेज मींस वोल्टेज के लिए फॉर्मूला क्या था, वर्क डन पर यूनिट चार्ज, वर्क डन पर यूनिट चार्ज, denominator of the denominator comes to numerator, correct na, then this equation will become Q into Q means it will be Q square divided by work done. Guys, try to zoom this one, zoom your screen towards the screen where I'm writing. Okay, actually ये बहुत छोटा दिख रहा है मुझे पता है, zoom your screen. Okay, आ गया देखो Q know that from ampere only we will actually current I is equal to Q by T. From this point we will write Q. Q के लिए I into T is equal to Q will write. Q means coulomb charge. Charge के लिए क्या लिखता है हम, I means ampere, time means second और T. करेक्ट ना, यार coulomb Q square is there means coulomb के लिए square करना है. Square करने से क्या मिलता है आपको, ये square and then time square divided by work done, divided by वर्क डन. वर्क डन के लिए फॉर्मूला इट इज नथिंग बट एनर्जी. एनर्जी के लिए डायमेंशन फॉर्मूला क्या होता है, m to the power of 1, l to the power of 2, t to the power of -2. correct na, actually it is in denominator, try to take this one to numerator. When you are going to bring this to numerator we will get m to the power 1, l to the power 2, t to the power of -2 था. इसके लिए क्या होता है, माइनस प्लस, sorry minus itself it is, sorry guys, just pardon. Okay, minus it will become +2 and then here देखो a to the power of +2 है and t to the power of +2 है. here t same basis at the index, then we will get m to the power of -1, l to the power of -2, t to the power of 4, a to the power of 2. This is the dimensional formula for capacitance of the capacitor. Cross check this one. Arey yaar, you can't able to write Q directly. It should not like that. Okay, is it clear, right? Purnima given a correct answer. Well answered. Rajat, is it clear? Yashaswini, is it clear, right? Oh, cross check karo Yashaswini. Okay, you can't write the Q value directly. Good. And remaining, what about remaining guys? Bharat, Reddy, Chandana, Devegowda, is it understood? Sagar, Sakshi, Sanket, Sinchana, Tejaswini, Swati, Itish, Are Captain, Janvi Mandya, Bhuvan, Manthan, Gayan, yes bro, good. Okay, done. If it is done means we'll move on to the next concept, capacitance of the isolated spherical conductor. क्या है isolated spherical conductor? We already know, right? Conductor means conducting one material. Now we took here spherical conductor. Okay, sphere जैसे होना है एक conductor. उसका center वो है and देखो उसका radius small r है. Okay, I'm going to place a positive charge. The charge cannot go out. Yes bro, it won't go outside. Okay. Capacitance of isolated spherical conductor means, guys, it is very simple. Isolated means single. Guys, last year क्या हुआ था, कोविड आ गया था ना, आइसोलेशन बोल रहा था ना सब कुछ. We kept them in a isolation. What is that isolation? You should be in a separate. Correct na? Look at here. Actually, these two parallel plates we took for a to made the capacitor. Okay, to construct the capacitor we took two plates. Two plates are actually in a coordination, they are present. Correct na? What I will do, I will going to take this one sheet outside. Correct na? Then remaining will be एक ही single होता है ना, single pasanga. Right? At the time we can call this one as an isolated. Isolated means single होना है. Clear? Is it clear? Okay. Capacitance, we have to find out the capacitance for the isolated spherical conductor. ये spherical conductor है, इसका capacitance find out करना है. Capacitance already I told you guys, एक actually भगवान से सील हो जाता है, इसका फिक्स्ड कैपेसिटेंस होता है, करेक्ट ना? ओके, ये स्फेरिकल कंडक्टर के एक कैपेसिटेंस किसके ऊपर डिपेंड होता है, वी हैव टू फाइंड आउट. ओके, दैट इज द, इसका एक कैपेसिटेंस होता है गाइस, सी वैल्यू होता है. ये सी वैल्यू किसके ऊपर डिपेंड होता है, डिपेंडेंट. ओके, उसको फाइंड आउट करना है एक कॉन्सेप्ट में. देखो, लेट ए चार्ज क्यूब बी गिवन to the system sphere which is assumed to be concentrated at the center. Okay, center के है, center के पास है. Okay, inside the center charge is there, just assume like that. The sphere has a radius r. Okay, due to this charge, due to this spherical conductor, we know the potential. Last classes we derived this potential value. What is that? V is equal to k q by r. It's a common, right? We write lot of time. That is what I am writing. For this spherical conductor, potential क्या होता है, k q by r. Here q by 4 pi epsilon naught into r. Same ही होता है. K value will be 1 by 4 pi epsilon naught. And we need to find out the value of capacitance. Means we will use this formula. Capacitance के लिए formula क्या होता है? C is equal to q by v. Don't forget. Now put this v value inside here. Okay, inside put the v value. After putting here v value, then देखो इधर क्या होता है चमत्कार, we will get c is equal to 4 pi epsilon naught into r. कैसे हो गया ये चमत्कार, मैंने बोलता हूँ इधर सुनो. Actually c is equal to q by v था, v के प्लेस में इसको क्या सब्स्टिट्यूट करना है, q divided by v means here again q divided by 4 pi epsilon naught into r. q cancel हो गया, 1 1, this is denominator of the denominator, it will comes to numerator. Then c value will be equals to 4 pi epsilon naught into r. This is the capacitance of the spherical capacitor. Okay, this is the capacitance of the spherical capacitor. Guys, this is very important. This is an isolated spherical conductor. I think after this it will not be k. Radius. Yes, bro. Yes, r means radius. Swastik, I didn't get your question, bro. I think after this it will not be a k constant. Yeah, it will be constant only k. I will tell you where it will be vary. Okay, I will tell you. Okay, no worries. Now देखो इधर capacitance के लिए formula आ गया हमको 4 pi epsilon naught times the r. देखो इधर 4 pi epsilon naught, it is a constant one, correct ना? K is a constant quantity, but here capacitance is depending upon the r value, correct ना? It has a fixed value of r. मान लो 1 meter है, okay, इसका value fix होता है k. Now if I put the value 1 here means capacitance will come out to be proportional to 1 meter value will become, correct ना? If the r value will be increases means बड़ा sphere लेता हूं मैंने, if I took larger sphere means r value will be greater होता है. At the time capacitance of the capacitor will be increase होता है. Means guys, for a single isolated spherical conductor, conductor, capacitance is depending upon the radius of that sphere. उसके स्फीयर के रेडियस के ऊपर डिपेंड करता है. देखो इधर कैपेसिटेंस ऑफ द स्फेरिकल कंडक्टर इज डायरेक्टली प्रोपोर्शनल टू रेडियस, इट इज डिपेंडेंट. एंड देन देखो द अबव इक्वेशन इज ट्रू फॉर कंडक्टिंग स्फीयर, hollow or solid, whether it will be hollow sphere or a पूरा solid sphere. okay, वो दोनों केस के लिए ट्रू है, दोनों केस के लिए ट्रू है, क्लियर ना? And then if the sphere is in the medium C, okay, medium means क्या होता है? Are you asking now Swastik? You are asking one question. Okay, value will be change होता है. When it will be changed means if the epsilon naught value is replaced by some other medium, okay, then the value will become E naught into ER. ER means relative permittivity we will call. Actually we discussed in electrostatics, right? क्या होता है electrical relative electrical permittivity will be epsilon naught divided by epsilon naught, like this. This is medium one. Okay, if you multiply the relative permittivity, then it will give the E value. At the time the capacitance will be changed hota hai. Correct na? This is for medium. Clear na? This concept is clear, right? Let me know in a chat box once. Is that clear, right? Yashaswini, Purnima, Swastik, Sagar, Rajat. Okay, done. We'll do one problem, right? Sir, if distance between our plates increases, then charge flow less hota hai, sir. No, bro. No, not like that. Actually, if distance will be increases means electrical field intensity decrease hota hai. If electrical field intensity decrease hota hai means the capacitance value decrease hota hai. We will derive that one in this class or tomorrow class. Okay, I will tell you that one also even. Okay, definitely I will finish properly that one. कोई problem नहीं. थोड़ा थोड़ा हो गया क्या? Where you got confused? Just give me a question. I will try to reach out that one. देखो इधर capacitance of the earth is 711 microfarad. Means guys देखो इधर what they are actually saying means our earth also sphere, isolated sphere. उसका जीवन संगाती कोई भी नहीं है अर्थ के लिए. करेक्ट ना? अर्थ के लिए कोई भी नहीं है. उसका कैपेसिटेंस क्या होता है पूछ रहा है. Capacitance means we got to know that for a single isolated sphere, whether it is a solid, whether it is solid or hollow. Okay, उसके लिए capacitance क्या होता है? 4 pi epsilon naught into r होता है. 4 pi epsilon naught का वैल्यू पता है ना? You know 1 by 4 pi epsilon naught का वैल्यू k, that is equal to 9 into 10 to the power of 9. Here 4 pi epsilon naught means divide, means 1 by 9 होता है, means 1 by 9 into 10 to the power of 9 into radius. Guys, yes, okay. Radius of the earth कितना है? 6400 kilometer है. Put this value here. 6400 kilo means 10 to the power of 3 meter. Right, what I'm saying? Solve this one. Okay, you solve this one, you will get capacitance of the earth. Capacitance of the earth, you will get 711 microfarad. Sir, you might be asked one question here. Sir, you told that capacitance we are measuring through farad, but you're writing here microfarad means it is not a logic one, right? You might be asked like that. Right, what I'm saying? I wrote SI unit of capacitance is farad. Correct na? Here I'm writing microfarad. Yes, guys. Why means whole chapter. Whole chapter we are not at all using farad as an SI unit. Farad as an SI unit we are not using because farad is an big SI unit. Okay, big SI unit. देखा ना, for our earth, okay, we got capacitance 711 into 10 to the power of -6 means microfarad मिल रहा है. Means 711 के पीछे 6 zeros you have to put. You need to keep a 6 zeros, right? Means for a sphere only we will get only this much of less amount of capacitance means, right? For our experimental evidence, whatever we are using, no, they all are lesser than this one. Small hota hai equipments. Plates will be very small. That's why we are dealing here microfarad, nanofarad, picofarad. Okay, micro means 10 to the power of -6. Nano means 10 to the power of -9. Pico means 10 to the power of minus 12. Like this, in this way, in this range, we are using the capacitance. Right? Clear now? We are not at all using farad. Only we are using micro, nano, picofarads for our calculation purpose here. Clear now? We'll move further. Principle of capacitance. I will tell you how the capacitor will get charged now. Okay? I will tell you now. We'll move on. I need confirmation from your end also. Maybe farad is a big quantity. Yes, bro. Yes, Rajat. Yes, Ashwini. Right now. Yes. Dekho. Look at here. Hey, what happened? Huh. Look at here. A and B. These are the two plates. Okay. A is actually get positively charged and B is neutral. Neutral means इसके अंदर positive charges and negative charges are same होता है B के अंदर. Correct ना? If I'm trying to bring, देखो second point, when neutral plate B is brought near A, charge are induced on B such that the side near A is negative and other side is positive. How it will be? Look at here. I will tell you in a second one. देखो, if I'm bring the second plate like this, no, near the plate A, positive negative charge will become like this outside. Correct now? And then other side will be positive charge will come, because here positive charge will only attract the negative charge. Right, what I'm saying? And due to do whenever we'll do like this, no, potential will be same, potential will not change, because इसके अंदर देखो इधर ये प्लेट के वजह से पोटेंशियल कितना बनता था, V वैल्यू कितना होता था, सेम पोटेंशियल विल बी प्रेजेंट हियर आल्सो, बिकॉज इसके अंदर क्या न्यूट्रल पॉइंट्स था वो सेपरेशन हो गया है. दैट्स इट. लुक एट हियर. द पोटेंशियल ऑफ अ सिस्टम A and B in step 1 and step 2 remains same, because potential due to positive and negative charge on B cancelled out. This will be again get cancelled because they are the neutral points here. Correct now? And then next thing, देखो how the capacitor will be charged. I will tell you. Potential will be same now. Now if I am going to connect this one to earth, means earthing कर रहा हूँ. When I do this one earthing, no, only negative charges will be remains on the plate. When negative charges will be remains on the plate, when negative charges are remains on the plate, now there will be a electric field will be start to develop between the plates like this. Okay, and this time potential not decreases, guys. Actually now this time potential value will be increase hota hai. Okay, at this time potential value will be started to increase. When potential value started to increase means here क्या होता है, electric energy will be store होता है. Correct ना? This is the principle of electric charge. Okay, what is the time right now, guys? Is it over? We'll discuss tomorrow then. 464. Sorry. Then I'm extremely sorry. I haven't checked that one. Okay, guys, tomorrow we'll learn about the capacitance derivation and parallel combination, and then series combination, everything. Okay, I hope today class is bit good. Tomorrow class is more good. Okay, we'll come across the tomorrow class with a good concept then. Until then, take care. Bye bye. Okay, guys, thank you. Bye. Don't know how the time spent. Okay, it's a good time with you all. Thank you. Bye bye.